Okay, let's unpack this. You sent us some truly fascinating material. It's about something that honestly sounds like science fiction, but it's very real. Rain-powered solar panels.
Right. It's pretty amazing stuff.
So our mission today is to really dive deep into how these things work, where they're being tested and, well, what they could actually mean for energy, especially in places where the weather's all over the map.
Exactly. It's a potential game changer for consistency.
You mentioned these aren't just standard solar panels. They're fused with something called Triboelectric nanogenerators, TANs. Can you maybe break down how they manage to get energy from, well, rain?
Yeah, absolutely. So what's really fascinating is how these tangents work. It's all about friction. They use these thin, flexible layers of polymer. Think of it like a specialized plastic. PDMS is a common one.
Okay.
And these layers sit right on top of the regular solar panel. When raindrops hit them, the friction, the actual impact and movement generates a small electric charge.
A small charge. How much are we talking?
Well, per drop, it's up to about 2.14 volts and maybe 33 nanoamps. It sounds tiny, but it adds up with continuous rain.
Huh. And these layers, they don't block the sun.
That's the key part. They're transparent. So yes, sunlight still gets through to the solar panel underneath. The panel still works, maybe around 14% efficiency. A standard panel might hit 20%, so there's a slight trade-off, but you gain the rain power.
Right. So it's not just about getting power from rain. What else happens when rain hits these things? Does it help, like, clean them?
It does both, actually. The force of the raindrops hitting the surface physically knocks off dust and grime.
Like a mini car wash.
Exactly, which is great for keeping that solar efficiency up. But also, the 10 layer itself has properties that help prevent dirt from sticking long term. So rain goes from being a problem that cuts sunlight to being, well, a helper. It maintains performance.
Okay, this is where it gets really interesting for me. Your source is zeroed in on Billings, Montana. Now, Billings gets a decent amount of sun, like 205 sunny days, but it also gets those intense thunderstorms, even hail.
Yeah, Billings is sort of a perfect challenging environment.
So how does this tech really hold up there? What are the actual benefits when you've got that kind of dramatic weather?
Well, think about it. Normally, heavy rain can slash the sunlight, reaching a panel by like 90%. Efficiency plummets.
Right.
But with Tings, you're now harvesting energy from that rain, the kinetic energy. Plus, those polymer layers we talked about, they're pretty durable. They add a layer of protection against things like hail impact and wind. Very important in a place like Montana.
So they're tougher too.
Seems that way.
Hmm.
And based on Billings' average rainfall, which is around 14.5 inches a year, the estimate is these tins could add about 5% more energy annually. It's turning a negative into a positive.
And it's not just theory, right? You mentioned the Metallark's Solar Tang pilot project. A 20 milliW project in Billings started testing in 2024. What did they actually find? What stood out?
Yeah, the results were pretty compelling. On
Okay.
rainy days, these panels were generating an extra 2 to 8 kilowatt hours per day.
Compared to 0 for normal panels on those days, right? Yeah.
Exactly. 0 from standard panels in heavy rain. That extra bit is enough to run, several household appliances for hours. For households in the pilot, this apparently translated to savings of around $1,200 to $1,800 a year.
Wow, okay.
And maybe the most impressive part, especially for Montana. After experiencing 12 hailstorms during the test period, no structural damage reported on the panels.
12 hailstorms, that's significant.
Very. And another interesting finding, 62% of the people involved felt they had better grid independence during storms. Less reliance on the main grid, fewer worries about outages, resilience.
That's a huge selling point. But, okay, it sounds almost too good. Every new tech has downsides, right?
Yeah.
What are the hurdles here, the limitations?
That's a fair question. And yes, there are challenges. The main one right now is cost. They're more expensive up front.
How much more?
Around a 28% premium compared to standard solar panels currently. Yeah, that's not insignificant. And as we mentioned, you do get a slightly lower peak solar efficiency because of that extra layer on top. And, obviously their big advantage is rain. So in really dry, arid regions, the value proposition is, well, it's less clear. Scalability might be limited there.
So cost, a bit less sun efficiency, and maybe not for deserts. What's being done about that? Is there innovation happening?
Oh, definitely. Researchers are looking at things like using graphene in the tang layers. Graphene's superconductive, so that could boost the electricity generation from rain. And they're also working on modular designs. The idea is you could potentially add these tang layers onto existing solar farms.
Retrofitting them, that could be huge.
It really could. That would make adoption much faster and more cost-effective down the line.
So when we boil it all down, the big takeaway here, it feels like it's not just about squeezing out a bit more energy. It's more about making solar reliable, truly all weather, solving that intermittency problem, especially in stormy climates.
Precisely. You've hit it. The core idea is shifting from just generation to resilience. We're moving beyond seeing weather as just an obstacle for solar to actually leveraging all kinds of weather. It helps push renewables towards being that really consistent foundational power source we need.
Especially in places like Montana, yeah.
Exactly. So while costs are still, a factor for now, the viability shown in these pilots is strong. With ongoing material science work and economies of scale, this could genuinely become a cornerstone technology for renewable energy grids, particularly in storm-prone areas.
It really makes you think differently about the weather, doesn't it?
Imagine a future where every single raindrop is actually helping power your home.
Definitely something for you, the listener, to consider. How could harnessing nature like this, in unexpected ways, change things for your own community? Food for thought.